And yeah, we should be having people joining. There we go. Welcome everybody that's joining the webinar here. It is the top of the hour. We're just letting everybody get their places here in the webinar, and yeah, go ahead and find your seats if you will. Grab a coffee quick, and we'll get started here in just about another 30 seconds or so.
Coffee grabbed. Good to go.
Check.
Check. Okay, good. At least as long as the majority of the panelists on this webinar have coffee, then we should be okay, right?
Right.
Although the majority of the panelists on the webinar have white hats. And then there's us, the 19% or something like that. Oh, there we go. It just bounced.
There you go, Joel. Does that make you feel better?
Yeah, a little bit. Except my hat's still downstairs. I didn't go get it. So, oops. Oh, wow. Dang, everybody just converted. I would like to point out in Clayton's office, if you look in the background, just below his black guitar. What kind of guitar is that, Clayton?
That is a Telecaster. No,
okay, so just below his Telecaster, he's got some sweet Ekahau tunes on his turntable there. So, you know what that reminds me of, Clayton? That's like a on Mario Kart, like one of the Koopa shells, and how they just like always spin. You know.
Hey Joel, I think you're gonna have to kill your download, Joel.
I think you're right. It wasn't important anyway. Don't worry about it. It didn't make it through. All those packets got dropped. That's good.
There we go. All right. Well, we've got everybody. It looks like there's still some people joining, but we'll go ahead and get this thing kicked off since we're already a couple minutes past the top of the hour. Apologize. We were doing a few things behind the scenes here, getting things ready, and didn't have a chance to jump on for some pre-webinar banter, at least much of it. So yeah, for those of you that showed up for the pre-webinar banter, our apologies. We will do better next time with the banter. Jim says, sorry, Jim. I know we let you down. We're gonna
stick around extra for a post-webinar extra.
Yeah.
All right. Well, let's dive into this important topic here, and yeah, let's kick things off. All right. So the topic this week is going to be on Wi-Fi in manufacturing and warehousing. I brought on a couple of special guests, if you will, some industry experts, friends of Ekahau, to help us with this topic. So we've got myself on the line, Jerry Ola. Joel, you want to introduce yourself?
Like the audio cut out because of my download. It's so close to being done. I'm gonna let it ride. So, hey, I'm Joel. I'm the technical trainer at Ekahau. There you go.
Right on. Scott, how about you? Who are you?
I am Scott, also known as the IT Rebel on Twitter, co-host of the Contention Window podcast and CWNE number 253.
Really been enjoying the podcast. Thanks for putting that content out there, and yeah, thanks for jumping on to help us cover this topic.
I appreciate it. I know everybody always listens for Tawny and not me, so we're good to go.
Right on. Yeah, it's a good dynamic. Keep up the good work. Joe, how about you?
I'm Joe Elliott. I'm a network engineer here at Milwaukee Tool. I do just about everything wireless. I don't have all the fancy certifications everybody else has here, but I've been doing it quite a long time, and I should hopefully have some of those soon.
Right on. You recently did get your ECSE certification, is that right?
Yeah, I did get my ECSE back in December. I'm working on my CWNE now, so.
Right nice. On. But yeah, you're no noob, if you will, to the IT industry, right? You do quite a few other things besides just Wi-Fi in your current role. Is that correct?
Yeah, that's right. I handle anything network related or voice related. So I do a lot of security. I do a lot of voice. You name it. I have to handle all of it.
Right on. Well, yeah, thanks, Joe, for coming on. And yeah, this was kind of a by design that I invited these two guys to join us. Joe coming from more of the what I like to think of as the boots on the ground, managing these networks day in and day out. And then we've got Scott that's coming more from the system integrator background that somebody like Joe is going to leverage to help him implement these solutions and design and deploy. So there's each of them have their own perspectives on these types of topics that we're going to be going through, and I thought it'd be a good dynamic to get some boots on the ground perspective to some of this as well. So a couple housekeeping items before we dive in. If you haven't joined one of our webinars before, you're in a listen-only mode, but we do want to interact with you throughout the webinar. So I've got also Clayton. I suppose I should have you introduce yourself. Clayton's going to be on helping us manage the Q&A and the chat as well. Clayton, you want to say hello?
Yeah, hey everybody. I'm just going to lurk in the background because it's pretty much what I'm good at. And occasionally I give a demo and contribute to the wireless community, but otherwise I'm just a troll. So
Right on. So he'll be helping out with the questions and the chat. So will myself and Joel as we're kind of going through these topics. But yes, leverage that Q&A panel. Leverage the chat. On the chat option, it defaults, I believe, to all panelists, but you can hit the drop down there in the two, and you can say all panelists and attendees if you want to interact with the the entire audience. Feel free to do so. On the Q&A side, that reminds me, let me just make sure we've got the upvoting option enabled. There we go. I'll just check the box for that. So yeah, for the Q&A panel, when questions are submitted, you should be able to see the question that's asked. And if you like the question and you have the same question, go ahead and give it a thumbs up. And that way we make sure we get those kind of higher ranked questions answered if we run out of time. All right, so let's talk about the agenda real quick here. So the agenda for this webinar, we're going to keep it kind of brief, but have some open dialogue as well as some live demo time allowing here. But yeah, the main two topics that I really wanted to cover on this webinar to keep it a bit more focused is talking about some of the challenges that are that we encounter in these higher ceiling environments that are typically associated with manufacturing and warehousing environments, and then also what are some of the other considerations when you're designing and deploying for covering very large, potentially open spaces. What are some of the unique considerations there that we have to take in, and then then going through with the experts that we have on the call here. What does a proper site survey and RF design look like for these types of environments? What does that process look like for you guys? What's your design methodologies? And we'll talk through that. And, like I said, we'll try and keep this as interactive as possible with the audience. And if you guys have some tips that you want to share or, some questions and things like that on any of those topics or others, please go ahead and submit those. All right, so the first thing we want to talk about is challenges in high ceiling environments. So what are we talking about when we talk about high ceiling environments? So this is a very typical, if you've spent any time in any kind of warehousing, logistic type centers, we're going to have these kind of big open boxes, right, with these high ceilings, tall racking. Some of the challenges here, we're talking, 30-foot ceilings is, very kind of typical around that kind of range. I don't know I've heard people talk about, these kinds of environments all the way up to 80 feet height. I would say most of the ones that I've been in are around that 30-foot range. Anywhere from 25 to 35 is pretty typical. What about you guys, Scott, Joe? Is that common in the environments you guys are in?
Yeah, it really depends upon, the type of industry that you're working with, but, anywhere from 30 feet up is pretty typical amongst most of the warehouse facilities that I've been in over the last few years.
Yep.
Yeah, and mine's the same too. I'm pretty much anywhere from 25 to 45 feet, depending if it's a manufacturing facility or a warehouse facility.
Yep. And would you say there's kind of a defining, usually, threshold that changes things from a design standpoint? Certain heights that you say once you're beyond a certain height, you're going to consider different design options?
That's kind of a two-part question for me. Yes and no. So yes, in the fact that, once you get up above, 20 to 25 feet, you start to rule out some of your options like omnidirectional antennas in certain instances. That largely depends upon the environment as a whole, though, and where we have to start looking at the racking, what's in it, how tall is the racking, what's our clearance above the racking to the ceiling, where we would mount the AP at, and things of that nature.
Yep. And I see Brad in in the chat there mentioned in a steel mill it can range from 30 to 100 feet. So yeah, that's a pretty wide range, and obviously going to greatly vary your designs, based on whether you're designing for 30 feet or 100 feet, where you're going to place those access points, what type of antennas you're going to use, that kind of thing. Yeah, so some other considerations, besides that 30-foot high ceiling that, where we're going to place APs, we also have some open space that we need to deal with, and that's created because often we have these kind of metal racks that often extend up pretty high, but they don't go floor to ceiling like we do in a typical office space. So they're not going to be a complete wall from an RF standpoint. And if we have these high ceilings that are 30 feet up, and we're, traditionally we put the APs in the ceiling, right? And now we're using omnidirectional antennas, or if we are using omnidirectional antennas, now we have this open space that's just, there's no attenuation, right? The APs can hear each other every time an AP transmits. Every AP that's on those channels or adjacent channels potentially could be hearing that other access point, right? So there's some things that are unique to these kinds of environments that we don't often have to think about or worry about in an office type space. So yeah, what are some common mistakes that can occur, if we don't factor some of that kind of stuff in? Taking a look at this photo here, this Wi-Fi deployment, it's kind of hard to see some of these. It's a pretty big space here in this picture, and a pretty small picture, but anything that jumps out at you guys, Joe or Scott, of maybe some mistakes in here that you would recommend not doing?
Well, first off, those APs are pretty dang close together.
Yeah, so I think what you're talking about is you've got an AP here. It's got an omnidirectional antenna on here, not super high gain, but higher gain than your typical little, maybe rubber duck antennas. And then we've got another one that's kind of hard to see here. And if you look really closely, there's another one down here. So yeah, where you're standing and in one of these aisles, we actually have 3 APs with omnidirectional antennas. They're all audible. Yeah, what potential problems could that create?
For my environments, I've seen it create a bunch of channel utilization and contention issues. Also, on the same sense, because of the racking not being a full wall, I've seen it where every AP in the entire warehouse can hear the other AP, and that's like in a 1 million square foot warehouse. So if you can hear 190 APs, it's not a good day for anybody.
Yeah, exactly. I think one of the key things that Joe touched on there was, for those of you that have taken ECSE, you remember the, want, don't care mentality, right? Of signal levels and how we, bill ourselves and things of that nature. The other important thing to remember is these omni antennas in this particular instance are truly omnidirectional antennas. So, you see some manufacturers that have omnidirectional antennas that are built into the access points that have electronic down tilt built into them already to kind of help prevent that AP to AP contention and hearing as much as you do from adjacent APs. However, in this case, when you use these particular omnidirectional antennas, right, these oil cans, if you will, are just strictly blasting out an omni pattern everywhere, right? There is no down tilt built into these typically. So that's something else to be aware of is, choosing the right antenna for the job.
Yeah, very good point. All right, so let's talk about, covering these large areas. So yeah, here, we've got a photo. This is, a very long, open aisle, pretty wide aisle actually in comparison to, some aisles. But yeah, what we're talking about is, how do we cover these large areas with Wi-Fi? Do we just place a single access point, in the middle of the room with an omnidirectional antenna on there? You can actually see we've got one right here in the photo. It's pretty tiny in this image, but is that enough to cover these large areas? And actually, if we don't have attenuation to work with, we actually can cover a pretty large area. Would you agree with that, Scott? Can we cover a pretty long, large open area with a single access point?
Yeah, absolutely. Just kind of a side discussion around that answer. I do a lot of work in LPV environments like stadiums and all. And if you put an omnidirectional antenna at one end of a stadium, you can hear that even at lowest power up to 300-400 meters away. So these are things that in an open space, right, there's nothing that diminishes that signal, that ends that propagation. So short of free space path loss, that signal is just going to continue on forever.
So yeah, if we need to cover these large areas, what are the options? We talked about, so far these omnidirectional antennas and, placing these things on the ceiling, is that our only option? That's what we're kind of used to maybe doing from your other types of typical, indoor environments, with office spaces and things like that. We're usually, using Omni antennas and placing the APs on the ceiling and calling it a day for the most part. But with these large open spaces that we need to cover, we've got some other options. We've got some other tools that we can leverage, when it comes to antenna mounting, right? So we can leverage things like, the walls themselves and using end of aisle mounting, as well as, overhead using different types of antennas, right? Scott, anything you want to call out on this?
So much. How long do we have?
We got a few more slides to unpack this, but
yeah. So you have to be careful. You have to look at your clearances, right? Because as we think of an omnidirectional antenna, right, that pattern coming out of that antenna is going to be much like an umbrella type mentality, right? We're going to have the waterfall, if you will, out of the antenna itself. So we have to think about what is our clearance from the top of the rack to where we're mounting the access point, and I've seen some people already call this out. They've put Omnis in our chat window. They've put Omnis in the warehouse, and they've turned the power down so that you're not getting a lot of adjacent and co-channel interference between APs, but they're running into issues because they're not able to get the signal down to where the actual user is or the device is in the warehouse. So you kind of have to make sure that you're accounting for the rack height and that you can get that spillover, if you will, effect out of the Omni antenna into the aisle where you need the signal.
Yeah. Joe, what about you? Have you guys experimented with different antenna mounting configurations at all? Have you found one that works better for you in your environments?
And so we actually do all overhead, but we have changed out what we do from doing. When I first started, we had Omnis up at the ceiling, and it just did not work for our situation. So what we ended up doing is swapping them all out for directional antennas, but they're just more of that focused radiation pattern right on the ground level, and that high gain really helps those clients out.
Right on. So you're doing overhead, but using some type of directionality on those antennas, not omnidirectional.
Correct.
Okay. Yeah, and let's talk through, the different options really. And there's three main options that we're going to call out here. There's the overhead Omni approach, and some of the cons there is, we're not going to get that penetration, right? These APs are going to be really high up. The signal's going to be going in all different directions. And the other thing to keep in mind is, we often think of this from a transmit functionality of the AP, which, is one piece of that, but the other side of it is the AP has to listen to the client, and it's bi-directional, right, of the antenna. So that means if we have an omnidirectional antenna that's on the ceiling, that means not only are we transmitting that signal in essentially all directions, but we're also listening in all the directions. And where are the clients, in these environments? That's where we want to be listening and focusing focusing that listening and the transmitting is towards the client. So that way we're not listening to all the other transmissions that are occurring from maybe other neighboring APs and other noise and interference that might be in the environment. We want to be listening directly in the the direction of those clients. So yeah, large coverage, some of the cons is the large coverage area. That might seem like a pro, but really in a warehouse type environment and Wi-Fi with limited channels, large coverage area is not a good thing. And again, same thing as I was just saying of the listening. If we're listening in all directions, we're hearing all sorts of transmissions that we may not want that AP to be hearing, and that may be causing unnecessary noise and contention on the RF medium. But yeah, some of the pros is, why a lot of times we do see these types of deployments. It's very fast and easy to deploy, for cabling purposes and things like that. Probably would you agree, Joe and Scott, that that's the easiest from a deployment standpoint to do these overhead Omnis?
Yeah, it's definitely the quickest. And I've also seen some issues because it's so easy where people will just go and add more APs right to the plan without actually consulting a wireless engineer, and it just creates more issue than what was there before.
Yep.
Hey, Jerry. Sorry, I'm kind of over here doing 100 things, watching the Q&A and the chat and all that sort of thing. But I ran into a situation one time where the access points had to be mounted so far away that we had to use Omnis because the cable length was restricting us. And it was a large open area. It wasn't in the racks. It was actually kind of open area in the warehouse. And so that was the solution until we could get another distribution panel to run those cables.
Yeah, that's definitely another big problem or challenge, I would say, with these large open areas that we need to cover is the cabling, right, and the limitations that we have with the cabling. Joe, have you had to do anything creative when it comes to, cabling, with fiber and that kind of stuff? Are you guys running copper and cabinets, throughout the warehouse, or what does that end up looking like for you guys?
Yeah, for us, we're running copper to cabinets out in the warehouse, and then all the cabinets have a fiber run back to our main distribution point. So it's been pretty easy. However, at the speed of which we work, a lot of times we'll have to throw up like a temporary switch until they can get that cabinet installed, and that's usually the biggest challenge.
Yeah. But yeah, it's a good point, Clayton. We have to, that's another consideration that's not directly on the RF side, but it obviously greatly impacts the RF if we can't, pull a cable long enough to where we want to put the AP because it's outside of the spec of the distance that we can run that cable. So yeah, there's definitely a lot of challenge that adds as well. Yeah, Scott, you want to kind of dissect what we're looking at here?
Yeah, sure. So this is actually talking about overhead omnidirectional antennas. This is a survey that I did recently of a facility that had that exact mounting scenario. So in this particular case, they had the AP mounted on the ceiling rail with the oil can type AP antenna mounted to that. And they had them kind of, interspersed throughout the warehouse. As you can see, it was kind of essentially 2 per aisle, and they would skip a few aisles and then do 2 more per aisle, spaced apart. This particular facility, I think, was probably somewhere around 400,000 square feet or so. But as you can see, we'll kind of move right to left in this image, if you will. So we'll start on the right side of the image where we see a lot of green, right? A lot of green is good. The Hulk is happy. But if we look at that, if we had the opacity of the signal propagation turned down some in the image, what you would notice is that in this spot where you kind of see the he's moving the cursor around for me. If you'll move to the center of that kind of green blob right there. So that whole area on the far right of the image is essentially just an open area, right? It's going to be some type of either packaging area where they're putting things in boxes, or they're, stacking pallets, putting merchandise on the pallets and things of that nature. So in that area, the closest access points with the omnidirectional antennas, we see great propagation, right? No problem, signal's good. This is obviously from the 5 gigahertz side, which is what I typically recommend people designing for these days. Even in warehouses, even though we don't transmit a lot of data, right, we still have to get to the point where more and more devices are supporting 5 gig, so therefore I want it out there for customers to use. But as we kind of move away from that, right, into the bulk of the racking itself, toward the left side of the image, you'll start to see that signal propagation fall off pretty dramatically, right? And this is where we're talking about, we've got an antenna mounted at about 33 feet. We've got racking that runs up to about 30 feet. So there's literally just a very minimal 3 to 5 foot gap from the top shelf of the rack to the antenna of itself. So as we see that propagation coming out of the antenna, right, we see very good propagation down the aisle, what I'll call same aisle as the APs are mounted on, but just one aisle over, we start to see that fall off pretty dramatically. And then as we move 2, 3, 4 aisles over, right, we see that significantly drop off. I believe in this, anything in gray is going to be below neg 70, I believe, in this particular picture. So, and then as we move, obviously, throughout the warehouse, right, you can see even more attenuation out of the propagation of the antennas on the far left-hand side of the image based on the inventory levels of the shelves in that particular area of the warehouse. So this particular facility does a lot. It's a distribution facility, has a lot of metal objects inside cardboard boxes on the shelves, right? So you can see how those materials affect that signal propagation from rack to rack and row to row.
Yeah, it's pretty interesting to see the difference, laid out like this across the entire building, where you've got, it sounds like to me, you've got the same APs, same antenna, potentially even the same transmit power configured on all these, but drastically different results from an RF perspective. And, all these measurements are being taken boots on the ground, about 1 meter or so off the ground. So we've got to get that signal down from the ceiling all the way down to the floor. And yeah, in a big open area, this design and solution appears to work quite well. But as we add all the density of the objects and the racking, obviously that changes things very drastically. So yeah, it's pretty interesting to see that, from right to left, how that changes. Good stuff. All right. So yeah, let's look at this comparison then. So here's our 5 gigahertz overhead Omnis in a predictive design model. What are we looking at here, Scott?
So this is the same warehouse facility. We were going to go in and just essentially completely do a greenfield deployment where we were going to have carte blanche access to redesign the entire facility. So what we did, or what I did, I'll say in this case, is you'll see the attenuation zones for the racks put in. Those were actually measured on site based on, just taking devices, seeing what the propagation was, using Ekahau in the Sidekick to determine attenuation between racks, to come up with an average, if you will, for the warehouse as a whole. Now, obviously, each rack is vastly different in certain circumstances, right? Based on inventory levels, materials in them, and so forth. So what I try to do is just come up with a generic average for the entire facility, and then I use that as my zone for kind of the predominant factor throughout the warehouse. So what we did is I laid those out, and then I went in and tried to utilize omnidirectional antennas to cover the entire facility within reason. And when I say within reason, right, there was a given budget constraints and things of that nature, right? So I figured out the maximum amount of access points that I could have used in the facility based on available budget and propagated the design and did as best I could, right? And you still see how in certain areas of the warehouse, you start getting tremendous signal loss, even in the predictive phase of things. And obviously, I think many of us can tell you that have done Ekahau for a while, Ekahau's predictions are only as good as the information you put into it, right? So, this is based off of the most accurate information that we could come up with, and we still saw significant loss from it. So you transpose that into a real world deployment, and typically it'll be close, but even in some cases in warehouses, right, you're going to see even worse as far as your overall design from a predictive to an actual deployment. So obviously this is something that wasn't going to meet the standard of need for that particular account and customer.
And Joe, you mentioned before that you guys had experimented with something that sounds like similar to this, right? Is this kind of the results you were seeing as well, doing these overhead Omnis?
Yeah, this is exactly what I was seeing. And the big thing that I learned doing this process, this is probably when I first started doing wireless. What I would go do the survey, but I'd never actually offset for what our clients were capable of. And that made a gigantic difference once you start showing what the clients actually see at that level.
Right on. And the, so I think one of the things that we'll look at next here is the other approach of the end of aisle. Oh, also before I move on, there was a question about the cutoff value here that we're using, or kind of the grayed out value. Do you recall what that was set to on this, Scott, as far as like it was at -72, -70?
I think what we had to meet in this was neg 67 or
Okay.
greater.
On
Jerry?
5 gigahertz.
Just really quick, because we're talking about predictive design here, I've seen a couple of questions come through about using attenuation areas versus walls to model the racks.
Yep. Yeah, when we get into the demo, I wanted to kind of I'm gonna show a couple of different approaches. There's more than one way to define these. What Clayton's talking about is these in the predictive model. Scott's used the attenuation area to define the rack. I'd say the old school way of doing it, which is the way I still do it, is the using the wall tool to define the racks. I would say both are, can be correct as long as they're defined, accurately. But yeah, garbage in, garbage out, right? So as long as we put the right values in those and define those correctly and understand how the tool works, either the wall tool or the attenuation area tool can be used for representing the attenuation of the racks. All right, so the other antenna option that we have is end of aisle. So this is kind of an interesting one. This is one that I have seen some of our customers use. This is one that I personally have not had much experience using. Scott, I don't know, is this something that you find has been pretty effective for you? Is this something you use pretty often? What types of environments do you see this working better in?
So this is going to be probably my second, I guess, favorite, if you will, if I categorize things, deployment method. Now, obviously, we'll talk about cons first, right? So the cons of this particular approach of using an end of aisle deployment is that you have potential obstructions. Okay, what do we mean by obstructions, right? I'm sure everybody's already figuring out, right? Those forklift drivers, you might as well put neon signs on these things if you put them where a forklift can get to them, because I can almost guarantee you in every warehouse facility, you're going to get a few of these hit. In this particular case, you can see that the access point is mounted to what we call a co-location bracket. We've got the access point there in the middle. You can't really see the antenna, but it's going to be on the bottom of that tilted metal plate there. And it's mounted to just a standard double gang wall box hanging off of the all thread. Now, in some cases, there are some nicer mounting options, if you will, that are available now that are essentially just large springs that are mounted to the ceiling, so that if the forklift hits it, you're going to get some oscillation, obviously, to it, but hopefully the oscillation of the spring will allow the access point to survive the direct hit, if you will. But overall, this is a good approach if you have aisles of a reasonable length. Obviously, depending on power settings and things of that nature, right? This works well with aisles that are, say, maybe 100, 150 feet long. As you start getting more lengthy in length of your aisles, say 200 to 300 or plus, I've been in some warehouses where we're looking at 500 to 600 foot aisles. Obviously, then you're going to have to look at a different solution, maybe. I've had some people ask me about mounting, in long aisles, maybe doing one of these on each end. But again, you kind of run into the same problem of, if the aisle is of a certain length, then you're going to have very low signal propagation in the middle of the aisle where your users are going to be. Also, as you have that forklift that, not only is a danger to the access point, but, trying to do their job and pull merchandise out of the racks, as that forklift drives down the aisle, right? If the antenna is in front of that forklift, then you're going to get fairly good reception for the forklift driver and the devices that they're carrying. However, if that forklift comes into an aisle where the access point is mounted, in this case behind the forklift, then you're going to start blocking signal, and you could start getting some issues with reception for the devices in the forklift itself. So it does work, but as always, you have to be cognizant of the situation that you're deploying that in.
Right on. Joe, have you experimented at all with this kind of end of aisle approach?
We have not actually experimented with this at all. However, we are looking at something similar for one of our facilities, so we can actually get Wi-Fi into the back of semi-trucks.
Oh, wow. That's an interesting way to do it. Yeah, that could work. saw a couple things in chat here about, I have not had any experience with this one, about the radiant leaky feeder cable. Joe or Scott, have you guys ever experimented with that one at all? I have not had any experience personally with that.
I personally do not like working with that at all. That's something that, several years ago in the heyday of wireless, when it first started back in 99, 2000, the early 2000s in warehouses, it worked. It didn't work that great, but it worked sufficiently for the 1-2 megabit per second, thresholds that devices back then needed. These days, the warehouses, they're becoming much more multimedia driven, and some of these devices that are through, on the forklifts, you've got people that are actually using real tablets, iPads, laptops, and things in the aisles doing inventory and so on and so forth. As well as, just robots and things of that nature that are obviously below that 1 meter threshold that we typically measure at, right? They're literally on the ground, driving around in these warehouses these days. So I just don't find that solution works very effectively these days. And then a second factor of that is that I find that most access point manufacturers don't actually support the use of that particular antenna. And just a side note, obviously this is not something that the FCC polices very tightly, right? But I feel it would be amiss if we didn't recognize that, according to the FCC, right, in most cases, the antenna that's used for an access point has to be certified by that access point vendor for use with that access point. And that's mainly to make sure that propagation and the FCC limits and things of that nature are enforced properly. So just something else to remember there when you're doing this kind of work. Now, obviously, we don't go to the FCC and say, hey, can you check this out? Or I really think that warehouse is probably using an incompatible antenna of that nature. But it is something that technically, to the letter of the law, you have to be aware of.
Yeah, right on. So there was some interesting during that kind of conversation. I was following chat a little bit there. There's a lot of activity in there, but there was some kind of mixed stuff. I saw a few, or at least one positive kind of comment about a customer that did successfully deploy this radiant leaky cable. But there was a couple of people that said that it works good for DAS, but not for Wi-Fi. So there's definitely more options than we'll get into on the webinar here today. But that's why we love having you guys on the chat there to introduce us to new things that maybe we didn't think about. One more antenna option here. This is the one that I've become probably most kind of familiar with, and I think Joe, correct me if I'm wrong, but I think this is kind of what you're talking about moving towards, right? The aisle overhead directional. Is that what you guys have been deploying?
Yeah, that's exactly what we've been deploying, and what we see is we get a lot less of that don't want that Scott had brought up earlier in the episode. A lot of the contention that we get from our clients when we had too much of that don't want was they would see really slow connections, or B, if the medium was too busy, it would sometimes just drop connection altogether, reset, and start over. So this was kind of the best of both worlds. It gave us higher capacity. It gave us faster speeds because we're doing more than just barcode scanners, but our barcode scanners are also our least capable device.
Gotcha. Okay. Yeah, and we'll talk about devices here in a little bit. That's a good point. Everything so far we've been talking about, really the environment and the APs and the infrastructure, but there's a whole other piece to this equation, right? The client part of it. So yeah, that's a good point. Anything you want to add to this, Scott? Anything from your experiences? Do you find you're using this more commonly than any other ones?
Yeah, so this has recently become my favorite deployment method because it solves the problem that we face from an omnidirectional antenna perspective of being able to tightly focus that pattern from the access point down the aisle where we want it. And we don't have to worry about, adjacent aisle interference from a different AP and things of that nature. It also addresses the problem of using end of aisle deployment method that we just talked about, in the fact that with the access point mounted in the middle of the aisle overhead, there's nothing that's going to impede that that signal propagating down the full length of the aisle, regardless of where a user or forklift or whatever may be down the aisle. So this has become a favorite and one that I'm actually deploying actively as we speak. So.
Yep. And this image looks like this is not a predictive image, right? This is an actual surveyed access point with this directional overhead.
Yeah, that's correct. This was one that we did in a warehouse facility, mounted the access point, a single access point with a dedicated testing SSID, and measured propagation for the adjacent 6 or 7 rows on each side, left and right of the aisle, as well as, to the north and south bounds of the warehouse walls, to get a good idea of what we're actually seeing out of the access point, and making sure that that pattern that the antenna is allowing is actually what we're seeing in real life propagation. This aisle, this actually is from a blog post that I did on my blog site, which we can all talk about, link later, or just ask me on Twitter, you'll find it. But I think in this case, the aisle was about 300-ish feet in length. So obviously the antenna and AP are mounted about midway of the aisle. And we lost Jerry.
I'm back. I was like a magician, just disappearing act. No, that's awesome. So I think, the real, success here is when you look at it overall, right? So this is taking that same concept now of the overhead directional and that same warehouse that we've been using and showing with the previous slides on the omnidirectionals and how much better the coverage is. I don't know if you know AP quantity wise, I would assume you probably are going to need some more APs with this approach, but from an RF, RF quality standpoint, you're going to get a much cleaner environment, right?
Yeah, absolutely. I think in this particular facility, we more than doubled the total AP count from where they had to what we went to. In some cases, depending on how the original design was done, it may be as much as 3x. So obviously, there is a much greater cost for this deployment method. But I think at the end of the day, you have to find a solution that works for the customer to meet the requirements of the project, both from a technical standpoint and a business standpoint. And in most cases, I've had a little bit of pushback from some customers trying to utilize the solution like this. But I think if you can show them, this actually is done from the same drawing that the passive survey that we first talked about for propagation in the beginning for Omnis was measured at. So I think when you can show the customer in real life that this is what you're currently seeing, this is what we recommend going to, and this is why we recommend going to it, and you show them attenuation loss between racks and things of that nature, right? Most cases, customers will be accepting of that, and obviously understand the time and expertise that you bring to the project, to the project then, to show that, hey, this is what, as the professional, I think is going to be your best solution.
Right on. And I do see a couple things in chat about, wanting to know the type of antenna that you guys use for this. Obviously, you don't want to particularly promote any one vendor, but if you guys do have some examples of antennas that you've used and have worked well in these types of environments, if you want to put those maybe in chat or provide a link or something to those, might be useful to our audience. I did see a question in chat about mezzanines as well. This is actually a photo that I took a while back doing a project. This was actually one of the most challenging ones I've done. If you guys have worked in environments, Joe, I believe you guys have some mezzanines in some of your facilities, right?
Yeah, we have that 3-story mezzanine that you joined me in that couple months back. I actually think that's probably the most difficult environment I've ever actually had to design wireless for.
Yeah. Mezzanines present some pretty unique challenges because you take the same concepts that we've been talking about with these aisles, and you basically kind of compact them, right? So, like in this case, these are essentially these metal shelves that go not floor to ceiling, but they go up pretty high, and they're much narrower aisles. So you can see it's really only wide enough for really kind of one person to kind of fit down here. If you have 2 people, it's pretty tight to squeeze past each other. It's just kind of big enough for one person and maybe a cart to fit down. and that's about it. And then you've got these metal shelves, and then on top of it, you've got a floor above and a floor below that you need to cover with Wi-Fi, and they're picking parts off of these small shelves, and you've got a lot of metal parts, and you've got all these metal racks, you got lighting, all this stuff that you have to deal with. So from an RF standpoint, this was one of the most challenging environments. What do you guys think, Joe or Scott? Do you guys have any ideas? I am happy to say that I was able to come up with a successful solution after some careful planning and engineering, but I'm kind of curious, how you guys would have approached something like this. What's your thoughts?
So from my experience, an AP on a stick was vital to the right placement on it, especially so you don't get too much channel overlap with the aisles that are right next to these mezzanines a lot of the time. The other thing that I found with this mezzanine area as well is how many people are in it at what given time. So when I first designed it, they're like, oh, there's only 5 people that work in each level of this. I'm like, okay, that's pretty easy. Well, come to find out, during busy season, there's about 25 to 50 people per level of the mezzanine. It's like, oh, all of a sudden we're not getting the throughput requirements that we need to be successful.
Yeah, so the interesting thing that I did find with this one is originally when I came into this project, they were really struggling to cover more than a couple aisles of this mezzanine. And this goes back quite a ways. That this is a pretty large mezzanine. It's hard to tell in these photos, but yeah, you can see this thing keeps going pretty far. And shooting down the sides wasn't really an option at all, because just to the left of this photo is another tall rack out here, and then on the other side of this is actually a concrete wall. So there wasn't really any easy way to do any kind of like what we talked about before of kind of shooting down the aisles. So the only option was to go overhead. The ceilings were about 25 feet. And thankfully, my concern was going to be that this metal grid, flooring above was going to block a lot of the signal. And thankfully, the spacing must have been wide enough, or it didn't have really any impact on the signal. So I was able to shoot down from above all the way through the second floor down to the first floor here just fine. The tricky part was just getting above this racking structure for the cablers to get in and actually install these directional antennas. So I actually took that same approach that we've been talking about, the overhead directionals, and we put several overhead directionals over the top of this mezzanine and shot down from above to below. So we were able to cover the second and the first floor with those directionals over the top, where before they had like, I don't know, probably 6 different omnidirectional antennas between the first floor and the second floor that they were trying to cover, and they couldn't even get halfway down the aisle before the signal was pretty much non-existent with all this metal. So yeah, the only option was to go from over the top down. And yeah, same concept. I think when you've got 2-story or 3-story, it depends on the flooring. Obviously, is the biggest factor there. If you've got solid metal floors, you're going to have a hard time getting through that. You're going to have to come up with a different solution. Thankfully, in this case, with that metal mesh or metal kind of grid flooring, I was able to leverage that to get the RF through. Well, cool. I think we're doing a little bit behind on time, but I think this has been some good stuff. I wanted to just talk about quickly Wi-Fi design methodologies, and then apply some of that, see if we can apply some of that in some kind of a live demo here in the Ekahau application. So yeah, Joe, why don't we start with you? Talk about, what is your Wi-Fi design methodology today? I don't know how much detail you can go into with some of that kind of stuff, but at least just, what are some of the concepts and stuff behind that? I listed a few bullet points on here of some of the common things that we see our customers doing. But yeah, does that align with what you guys are doing? Are you, skipping some of those steps? Are you adding some other steps in there? You are doing any kind of proactive?
I'd say we were picking and choosing quite a bit. So we always do a predictive design through Ekahau. And then depending on the circumstance, if like the mezzanine we were just talking about, I'll do an AP on a stick there every time just to make sure that we get the coverage patterns we need. But otherwise, we'll go through and deploy part of the building sometimes and do a hybrid. So you just validate that, yeah, what Ekahau says it should be is what we're really seeing. And then we'll move on from the project from there. And then once the project is finished, we'll go through, do the post-deployment validation survey. The biggest challenge I find with it is that everything around here is needed yesterday. So we can't get it done fast enough. So I don't usually have the time to do a complete AP on a stick survey unless it's possibly a brand new site that they're not using or don't have occupancy to yet. But that's really my.
What about once the network is stood up? What do you guys do after after the network's there? Do you just kind of wait for complaints to come in? Are you guys doing any kind of proactive surveying?
We're doing proactive surveying for sure. So we have two different things that we do. Once the network is stood up, we go out and validate with Ekahau, but we also carry a couple of clients with us just to make sure that they're not losing connection, just monitoring what's going on with them as well. And then also beyond that, because this is our most critical area is our warehouse, we actually are proactively doing a survey every 3 months, not just because of changes that may have happened to the network, but they may have gone through and changed the layout of the building, and all of a sudden we're not meeting requirements anymore.
So like something like this could have an impact on your design.
I was going through the slide deck earlier, and I just started laughing. I'm like, yep, I've dealt with that. I've dealt with that. I've dealt with that. So
yeah, this is kind of an interesting one because not only do you obviously, this used to be an exterior wall that they expanded out further, and you have this concrete wall now in the middle of the building, but then also up on top here, you've got these, I don't even know what these are called here, but this is metal up on the top. So, if you're not aware of that when you do your design, or these get installed or something, gets moved, and now all of a sudden this is right up next to an access point that you've got on the ceiling, obviously it's going to create a big shadow, big impact to the RF.
Yeah, and that was an interesting one for us when they did the expansion. We had that external concrete wall, just like you're showing, and so this was before my time. They hired an external company, a system integrator, come out, and they never counted that was an exterior wall. So there's just a giant dead zone on both aisles going down that concrete wall.
Yeah. How about you, Scott? What's your do you have a typical Wi-Fi design methodology? I'm sure it depends for you with all the different environments and stuff that you're working in. But if you had to try and kind of form that into a common methodology, what does that usually look like for you?
So for me, obviously we're going to do a little bit of probably every solution out there. So typically I'll start out with recommending a passive survey of the existing facility to see where we are. If this is a greenfield facility or a brand new facility where they haven't deployed wireless previously, then obviously we try to get as accurate a drawing as we can. The number one issue I would say that I typically face in warehouses in general is getting a map, and in some cases that's any map. The more accurate the map, then the better that we can do our job from a predictive standpoint. After that, then we'll obviously in that predictive phase send somebody on site, make sure that if the facility is populated, that we can measure the attenuation values and things like that to properly form our predictive. Then we'll go in and do an AP on a stick. Now, I saw a question earlier. Somebody actually asked, how do you do a project like this when the customer doesn't want anyone on site? They just want to provide a drawing, and then they want you to do a post installation validation survey to make sure that what you put up worked. In that case, what I try to always recommend is encourage your customer to let you come on site. Even sometimes if it requires you to take the expense out of pocket initially to make it up on the back end of the project, we really cannot do our job effectively as professionals, even with amazing tools like Ekahau, without having as accurate information as we can up front to do these designs work, to do the design with, and then test. So once we've done the design, then I'll go back in certain instances if I think it may be, there may be a ceiling height issue or a clearance issue or something like that, and we'll set up an AP on a stick. It may only be one spot, it may be 5 spots. You know, we may be doing 5% of the total access point count in the facility for what we designed. But as long as you're comfortable based on the results that you get from your predictive design, and you can validate those designs then with your AP on a stick survey, I would say in 95% of the cases, you will be successful when you deploy that after tuning and all, and make that match with your predictive, your AP on a stick, and your post-install validation. Those are really 3 key steps to doing this. If you can't go on site, then obviously, like Jerry said, like I said earlier, you know, your design is only going to be as good as the information that you put into it. And if you don't have accurate information, then your success rates typically fall drastically.
Yep. Good stuff. What about my AP on a stick here? You guys ever do anything like that?
Yeah, so one of there are essentially 2 options that I typically use a lot of. Zip ties are your friend in warehouses. I try to get these access points and antennas into places where I'm going to actually deploy them, zip tie them into place. I primarily use that method just because in a lot of the facilities that I do work in, they're still under active work. So they're actively pulling merchandise and shipping it in and out of the facility, right? So we can't stop business in a lot of instances to do this work. The second solution is like you have here, Jerry, in your picture, where you're using a forklift or something to get that antenna all temporarily into place. You know, at the end of the day, it's what will the business allow you to do? How can you be, you know, as less intrusive into operations as you can, and yet gather that information that is so critical to making sure that you do the job successfully the first time.
Yep. Yeah, and this is, you know, I kind of joke about my AP on a stick, because typically when we talk about AP on a stick, it is more of a stick, you know, that we're using, but in a warehouse and manufacturing and the high ceilings, we have to get a little more creative with the stick part of it and come up with basically a bigger stick. Joe, I don't know, do you guys do anything with like the AP on a stick type stuff, or, you know, do you have any kind of creative solutions to this part of the process?
Actually, I haven't had to deal with the creative part of this yet. Everything I've had has been a brownfield installation, so we've just did more of the hybrid. We'd install it near where we thought, we'd test it, and then at some week or some outage window, we'd just flip it over.
Nice. Okay. Yeah. So I saw a few things in chat about, you know, what is an AP on a stick? Yeah, usually it's, you know, it's literally some type of stick, something to hold up the access point in the antenna. I've even done things where we use some type of clamps and we clamp that to the ceiling. And that way we can remove the lift out of the way and leave that up there temporarily, but using some type of battery then to power it. Thankfully, we have some really awesome new portable battery solutions now from a couple of different vendors that we can use to power this equipment. So yeah, here, this is a few years old. So I was using a pretty large battery and PoE injector, I think, on the lift here to power the access point that I had hooked up to these different antennas. One thing I would say with this is, you know, if you're going to be working in these type of environments, you want to have a pretty wide assortment of antennas of different gains and you know, different directionalities, different angles on the antenna patterns, because we're going to need those in different types of environments, whether you're doing indoor or outdoor, you know, doing the ceiling mounted like we're talking about, or shooting down an aisle. So yeah, I usually would carry with me at these kind of sites, you know, maybe 10 different antennas. You can reach out to, you know, any of these kind of antenna manufacturers, a Celltech, Ventive, and usually they'll provide you some kind of a sample kit if you're in this line of work, where you can, you know, have these different types of antennas to use with you on site.
One thing I just want to point out, if you are using a lift, this seems like a no-brainer, but if you are using a lift, make sure it's out of the way. Like, make sure that the lift isn't impacting your access point, and so you have the antennas mounted in such a way that it's not traveling through the lift.
Yeah, that's a good point. Yeah, you do have to take that into consideration of your stick. If your stick is made out of metal, you want to make sure that that's clear of the, you know, where you're measuring that signal. Okay, so yeah, a couple other things. We talked about stock fluctuations. We showed the impact on the heat map, so I won't really spend much time on this. But yeah, make sure that if you're surveying, pay attention to what the stock level is, of the warehouse, and talk to the customer about that and see, is this normal? Is this low? Is this high? And take that into consideration into your design, your validation. This is one of these things that we've kind of overlooked, I would say, a bit in this presentation, but I think is very critical, is not all devices are created equally. Here's two different barcode scanners, an older and a newer one, right next to each other. The older one probably has been dropped a few more times than the newer one. And, just walking around with these two devices. So don't just grab one device. If the customer has 5 different models of devices, you want to test with all 5 different models, and maybe even a couple of each model to really get a good baseline of what the capabilities are of these devices. But some of the things that can vary is, what are the devices' max transmit capability? What does their receive sensitivity look like? What channels are allowed? Is it 2.4 only? Is it dual band? Does it support all the 5 gigahertz channels, or only, Uni 1 and Uni 2, Uni 3 channels, but not DFS channels? Those kinds of things to be aware of. And then, is it a fixed device or a mobile device? Is it something that's fixed to, a forklift and it's a, larger antennas, those kinds of things? Or is it, a very small handheld device that, somebody could be, putting in their pocket, or, sticking somewhere that's going to have worse receive sensitivity from that. But yeah, here you can see we have a pretty big dB difference between these two devices, and you can notice the impact on the transmit retries with that as well.
Jerry, I'll add one thing too on the devices themselves, is not only be aware of what channels they support, but try to find the documentation for the device itself if you can. There are some scanners out there that I've seen. I believe they were Intermec scanners, some of the older models in particular, that supported all 5 gigahertz channels. However, when you started drilling down into the details specifically, they supported a Uni 1 channel at, say, 50 milliwatts transmit power. They supported Uni 2 channels at, say, 25 milliwatts of transmit power. So something to be aware of as well during the design phase when you're picking channels is making sure that you pick a channel that's going to have similar characteristics across the spectrum of the device, right? Because we don't want to really get into the scenario where we have to say, okay, well, if we're using channel 132, we have to broadcast at 25 milliwatts or something. Or if we use channel 48, we're going to broadcast at X power, right? So something to be aware of as well that could cause fluctuations in your design as far as what the device sees.
Good stuff. Joe, anything else to add on the device side?
I'll echo what Scott said. You really need to understand what your device does. Leverage things like the FCC website. Also, if you can, my favorite way to see what a device is capable of is grab a packet capture of it associating, and see what channels it says it can actually handle, because I've seen the documentation be wrong before on some of the older devices.
Yep, definitely. Good tips. Well, I see we are already at the top of the hour. It took a little bit longer to get through that content, but I think we had some really good dialogue with the audience and questions. Clayton, do we have some questions that we were not able to answer yet?
Oh man,
Gazillion.
just a couple, huh?
Yeah, I've been trying to type as we talked, but
apparently this is a popular topic.
Yeah. So there were a couple that are very popular here that have been addressed. One that pops out to me here, again, going back to that attenuation areas versus wall, using a wall to define the racks in predictive designs.
Yeah, so let's talk through a couple of these questions, if it's okay with our special guest experts here. Do you guys have maybe another 10 or 15 minutes to stick around and try and answer some of these questions, or as many of these questions as we can?
I'll stick around.
Awesome.
That's gonna greatly change the hourly rate that you guys are paying. So.
We're going into overtime. I don't know if we can afford Scott's overtime pay. All right, so here's the first question here from Nick. It looks like was the most upvoted question here. So yeah, what do you tell a customer who insists that he does not want an on-site survey? We have one who wants predictive modeling and an exit survey. We know that this is not a good idea, but what do you tell a non-technical person that will convince them otherwise? Very good question.
I think that goes back to what I kind of talked about earlier, where, if you can get in and provide some sort of passive survey of what they have currently and show them where the shortfalls are in the process of their existing coverage model, or if you even take some of the images that we provided in the webinar today that'll be provided to everyone recording wise afterwards, and just kind of point out to the person and show them how that signal is going to propagate down the aisle, and how those variations in inventory levels, rack heights, clearances above the racks to the ceiling, all of those things are going to come into effect when you start looking at providing a solid design for the customer. And I think typically most customers, even the non-technical ones, once you show them, the graphics, if you will, the predictive surveys and things of that nature, the work that you've done, they too should be able to understand that and know that you're not just trying to, sell.
Very good. Clayton, what's the next question we've got?
So the next question that got upvoted as Scott was giving his answer is, are attenuation areas the best way to account for rack width? Seems like people want to know.
That's just a question from that no-name guy. Oh, that's actually Kevin Parsons.
I know, it fooled me too, because it's got the same first letter and the number of letters.
Is that Keith's cousin? Sorry, Kevin. Yeah. So the attenuation area is the best way to account for rack width. That is actually something I think we can do a quick demonstration of. Joel, are you still on the line and able to,
Yeah, I totally am. So what you want to demo the difference between walls and attenuation areas? Is that what you want?
Yeah, exactly. So I mentioned this during the slides of how do we account for those racks? The attenuation of the racks, and there's two different ways that we can do it in eCal, right? Either the wall or the attenuation area. You want to show how we would use either one of those, or how we
sure. Yeah, so let's do a wall first. And I don't know, Scott and Joe, I might have you guys call out some attenuation values, because I don't have any warehouse experience. And so maybe you can tell me, kind of what some realistic values to put in here are. So first way is to use a wall. So what we could do with the wall tool is go grab, there's a warehouse shelf preset in here. And we're going to say, like, by default, it's going to wipe out 27 dB as RF passes through it. And so when you draw a wall, basically you're drawing a line from one end to the other, and we're just going to basically predict what happens to RF as it passes through that. You can also define a width to that. And so if we edit that, we can say the total width of this is currently 4.92 feet. I don't know, Scott and Joe, is losing 27 dB through that, I mean, is that realistic at all? Like, what's kind of like a realistic value to put in there?
It again depends on the warehouse. I mean, let's just say for sake of the argument, let's use say 6 or 9 dB.
So 6 or 9 dB. Okay, so we'll just go with 8 dB.
27 equals a fully stocked shelf of metal parts.
Okay, cool. So that's like a bunch of transmissions for trucks or something like that.
Yeah, worst case scenario.
Yeah.
And so then what's like a typical warehouse width of a rack that you would see?
What's a Joe? Joe, what's a pallet?
I don't know what a pallet is off the top of my head, but
7-8 feet, something like that, maybe total.
So
8 feet is what I generally design for.
Okay, so we'll say 8 feet, and so now let's go ahead and turn on our signal strength. And so we've got a directional antenna that I just placed 20 feet off the ground with 45 degrees of down tilt. And so here you can see that I've defined those options right here. And so that's what it looks like when we use a wall. So then the other way that we could do this, remember, we've defined the height, the width, the total amount of attenuation as RF passes through that. The other way that we could do this is to define an attenuation area. So what we can do here is, instead of drawing a straight line, we can essentially draw a box, a long rectangle. And then we can let's change what that attenuation area is. We'll go grab the warehouse rack here. So attenuation areas work just a little bit differently. This one says, like, okay, well, how thick is this in total? and how many dB are we going to lose per meter as RF travels through that. So notice that this says, okay, we're going to lose 18 dB of RF per meter that we travel through it. So the thickness is defined by basically how wide your attenuation area is. So we could grab the scaling tool. We could actually look and see what did I define there. So I defined a 9 foot wide rack there. Now to
practice that ahead of time.
No, actually I totally did. I just grew something. I'm just really good at using Ekahau, Scott. So not really good at wireless design, but I am good at using the tool, making the tool look good. So one thing that we can do too to make that a little bit easier, it's like, so I'm doing this in feet or in freedom units, as I like to call them. But what can make that a lot easier to calculate that is if we actually switch over from feet to meters. That can make this a lot easier, because now when we look at that, how wide is that in meters? So if we look at that, okay, that's 3 meters wide. And so you can basically do the math there and figure out, what that's going to look like in the real world. So that is, let's just run the signal strength visualization one more time. And there we go. So now you can kind of see 2 different ways of doing the same thing. So Joe and Scott, what is your preferred way of handling racks in warehouses? Do you use walls and make them wide, or do you use attenuation areas? Or do you do both?
I mostly do walls, and then copy and paste is your best friend if you have a lot of racks that are the same length.
So you'll kind of define one thing. We can do that with, so here I just did a Control C and a Control V, and now we can start placing some, and we'll do a couple with the walls as well.
Well, I think what I use is pretty evident. I like attenuation areas better. I feel like from a graphical standpoint, it does a better job of actually representing what the actual width and all of the rack space looks like in the environment. And obviously from a integrator standpoint, right, a lot of what I do is provide reports and things of that nature to customers to show, represent these things in real life. And sometimes if you use a wall, even though they have the same identical attenuation values between the two, it's a little bit easier for customers to see the attenuation area and immediately understand what it is versus just seeing a wall drawn into the picture.
Yeah, absolutely. I got to say that, yeah, that is a pretty compelling argument for why to use attenuation areas versus walls.
And I'll add on to that. Scott is in a different situation. I almost never generate a report whatsoever because it's only for internal use. So it's whatever is easiest for me.
Totally.
Yeah, and I'm with Joe. I guess I feel like I'm kind of stuck in my ways and doing it the old school way, because areas, the area attenuation tool is newer than the wall. We've had the wall attenuation tool much longer than the area. So I started on walls and just got used to it and kind of learned the quirkiness or whatever of that, and know how to work around those things. So I guess I'm just kind of stuck in my ways. I think both work well. You just have to understand the differences between the two. The biggest mistake that I see made when using the wall tool is people draw a wall around, like a box around the entire rack.
Yes.
And where you see how Joel just drew a straight line and defined the width of that. That's the proper way to do it. You don't want to draw a box around there using the wall tool. Similar to how the area attenuation tool draws a box. You don't want to do that with the wall tool, because now you're saying there's attenuation in both directions of that wall around the box.
Well, and think about it too from the perspective, not only do you double the wall, so you double the attenuation, you actually have free space path loss calculations in between those two walls as well that change and make the attenuation even greater. So, you're not just doubling it, you actually in some cases could be over doubling it.
Yeah.
Actually, in all cases, I guess I should say.
Yeah. Yeah, so there you can see Joel drew using the wall tool, that box around the rack, and that's you definitely don't want to do that. That's definitely going to skew your results. I did see a couple of things in chat real quick here before we return to the questions. Is how do we define that directional down tilt that we were talking about? You want to show that real quick, Joel?
Really great question. So I did that ahead of time when I was just kind of setting up. I had a feeling that we were going to do a quick last minute demo. So when I place a simulated access point here, what we can do is you can set the height right here. And this is brand new in Ekahau as of yesterday. By default, All two, or in this case, all three of our radios get the exact same height. They're all 6.1 meters off the ground. That's about 20 feet. No, I did not do that calculation in my head. I can't do that. I let Ekahau do that for me. So we can set the height right there. So they're 20 feet off the ground. And then if we click on the ellipses icon here, we can, maybe not, if I click on that, there we go. We can actually define the down tilt right here. So if we change, let's do like a bulk select on all of these. So I'll just select all of them, and then we'll edit the selected radios. If we change those to 0 degrees of down tilt, notice that the elevation, tilts up now. This is what would happen if we just pointed all of those, or did it not apply for whatever reason? What did I do wrong? Okay, let's try again. 0, we check it, and then we hit OK.
Oh, you got it. It shows on my screen.
What's that?
I don't know. It might be just lagged, but it showed it was unchecked on mine.
Yeah. Okay, let's try that again. We go to 0, and then we go to OK, and there we go. Watch as the technical trainer learns how to use his own software. So now we've changed the model. So all of those antennas are just pointing straight out across the top of the warehouse. They're not getting that proper down tilt that we might want to apply to get that coverage down to the floor where it's needed. So that's how you change all that.
That would be similar to if you're designing more for that end of aisle, right? Although Scott, you probably put some type of down tilt on there, right?
Yeah, so typically when I'm doing the overhead middle of the aisle shots, if you will, with the highly directionals, I'll position the AP, and then it'll be a straight down. So it should be -90 in most cases.
So let's do that real quick just to kind of illustrate what Scott's talking about here. And so here's our AP. And so what I can do is I can basically just right click on it, and we'll just do it over here. We can hit the ellipses, and then we can say -90. And so watch what happens to our elevation pattern. Now that's pointed straight down. And this is probably the completely incorrect antenna to do this job. It's probably too narrow of a beam width, but you get the idea of how I did that. Now we've pointed that antenna straight down. And that's the beauty of predictive modeling, is you can play with antennas and figure out which antenna. I'm super lazy. I look at which antenna I want in Ekahau, and then I go, do the rest of the specking out on the antenna. So that's Ekahau is how I select antennas. That's probably wrong. That's how I do it.
Hey, Joel.
Yeah.
While you're here, there was a question earlier about the visualization height. So if I have my APs up at 30 feet, is Ekahau displaying the wireless signal at 30 feet?
That is an excellent question. By default, it is showing a signal strength 1 meter off the ground. Now you can change this. It is it's kind of a hidden feature. So this is what does signal strength look like 1 meter off the ground? If we hold down the Alt key or the Option key, if you're on a Mac, then you get this visualization height option. So what if we want to know what does signal strength look like 5 meters off the ground? We can change that to 5. And then now Ekahau will now visualize, okay, what does signal look like 5 meters up?
Very helpful if you have hand scanners that need to go down to the floor, right? You got to get that bottom shelf.
Hey, Joel, which version of Ekahau Pro are you running here?
Oh, that's a great question. I am running Ekahau Pro 10.0.1.
Yeah, notice one of the things that he just demonstrated there is new in 10.0.1 about the down tilt of the AP. Previously, you had to edit each radio individually, and now the rotation and orientation, they're linked together. So when you edit one of those radios of a specific AP, the 2.4 and the 5 radio in this case, it should adjust the orientation for both.
So I just edited the 2.4. If we head over to the 5 gigahertz radio, oh, look, it's exactly the same because it's literally the same physical antenna. And I know you can unlink that. I actually don't know how. How do you unlink
under
those?
the edit, under the actions.
Oh, okay, gotcha.
You have the AP selected, and then go to the actions menu there, and you can change it.
Right click on it, unlink antennas, boom, there it is. So... Well, we're about 17 minutes over, so I know there's a ton of questions, and I would love to answer all of them, but at some point we should probably get this thing wrapped up. What do you guys think?
All right, so we do one more question. We'll take the top voted one here. We've got one more from Joe talking about can we talk a little bit about legacy 2.4 gigahertz devices like label, printers, and barcode scanners in these instances? Yeah, Joe or Scott, you guys have any kind of experience dealing with that? Joe, are you guys still leveraging any type of older printers or anything like that in your environments that leverage 2.4?
Actually, no. All of our devices are 5 gigahertz capable, except we had one new device, and this is brand new, that they brought in that's 2.4 only on our 5 gigahertz only design.
One
And
brand new device that's 2.4 only. Interesting.
yeah, so the devices for forklift operators, they have to log in and it downloads what they can and can't do with it, like top speed, or if they get in an accident, it reports it back to us. So all I ended up doing for that is spinning up the 2.4 again and then making it a 2.4 only SSID.
Okay.
Yeah, so I see a lot of 2.4 devices still in warehouses. So when I say designed for 5 gig, obviously I don't mean alienate your 2.4 entirely. We still typically do provide both bands in the warehouse. And then as far, some people recommend splitting, SSIDs, say having a warehouse, and then a warehouse 5 gig or something of that nature. So you split bands between the SSIDs, warehouse fast, warehouse slow, however you want to name them. It depends on the manufacturer. If you have some of the proprietary tools like Aruba's Client Match and things of that nature, splitting the bands, you don't really see a big difference in preferential treatment between what the device chooses, whether it's 5 gig or 2.4, with all things being equal from a coverage perspective. What I typically recommend doing, though, these days, if you are looking at 2.4 gig devices in your facility, try and utilize something like a workgroup bridge, or something of that nature that will allow you to use, if you will, an enterprise class radio to communicate back to the wireless network, and then have an Ethernet handoff on the backside of it. I've successfully used those in a number of warehouses. Some of them are good for single devices, depending on what you're looking at. Some of them have, like I think HP has a workgroup bridge, the Client Bridge 501, I believe is the name of it, that you can actually hang multiple devices off of on the backside. I think it's got a couple Ethernet ports, and you can even, if you needed to, put a switch off of it if you had a centralization, if you will, of, say, manufacturing equipment, printers, older devices that may not have as good a radio as you would typically like to deploy or in the warehouse facility. So those are just a couple things that I typically look at.
Awesome. Very good stuff, guys. Well, I appreciate you guys sticking around well past the top of the hour here. Appreciate all of our attendees that are still on listening to us go on and on about this. And I'm sure we could stick around for another hour just, talking about all sorts of other different angles that we can go down this path about warehouse and manufacturing Wi-Fi. We've really just scratched the surface on here. But yeah, I want to be mindful of your guys' time. So we'll go ahead and wrap it up here for now. But if you did have any questions, I know we have plenty more that are still open that we didn't get to answer. I apologize for that. If you have a pressing question, hit us up on Twitter or shoot us an email. We'll be happy to try and get take that offline there with you as well. But yes, thanks everybody for joining. We did record this, so we'll send out a link to the recording here shortly. And yeah, thanks. Thank you to our special guests, Joe and Scott, for helping us cover this topic that was well over my head, and I learned lots of new stuff along the way. So thank you guys.
Yeah, thank you. I appreciate the opportunity.
Hey, thanks everybody. We'll see you soon.
All right, bye-bye.
Bye.